working with whatever I could get my hands on. Okay, so here's my myosin molecule. Okay, got it? Myosin molecule. Here's the little heads on it. See, little myosin heads, and they move. And there's like a, remember that this part has an ATPase enzyme on it. Okay? All right, there's that part. Then, and again, not to scale. Okay? No. Put your phone down. Seriously? Okay, so here then is the actin molecule. Okay? All right. So in the actin molecule, remember, and again, not to scale, right? Because it's kind of falling apart, big time falling apart. Okay, so the actin molecule has two other proteins with it, right? So this part would be like the main actin stuff, and then troponin and tropomyosin is this stuff. Okay? All right, so here's the deal. These two things in the sarcomere are completely lined up. Okay? So, myosin has a thing for actin. Okay? So, because myosin has a thing for actin, if actin doesn't have interference, myosin is going to latch on. Okay? And they're going to hook up. Alright, so these little myosin heads have little, or the actin has little binding sites for the myosin heads. Okay? But troponin and tropomyosin gets in the way. Okay, so, and if you look, when troponin and tropomyosin get out of the way, yay, that's really sad looking. There's little binding sites, see, there, for the myosin heads, okay, but they get in the way, okay? So, myosin totally wants to hook up with actin, but troponin and tropomyosin get in the way, okay? So, okay, remember the sarcoplasmic reticulum? Yes? Okay, what is the primary function of the sarcoplasmic reticulum? What does it do? You know where it is. It surrounds the myofibrils, but what does it do?
Calcium.
Calcium. Okay. So, we are going to call, we are going to call the sarcoplasmic reticulum a barn. See? It's a little barn. And inside the barn, what would you find?
Calcium.
Calcium. Okay, see? And here is calcium cow. Get it? See the +2 charge? Get it? It's calcium. Okay, so she's the superhero. Okay? She's the superhero to come and save the day. Alright? So, we have the sarcoplasmic reticulum, and this is her barn, her lair, so to speak. And so, this is where she lives. Okay? So, here's the problem. Troponin and tropomyosin are in the way, interfering with myosin and actin hooking up. Okay? So, calcium cow to the rescue. Yay! So when calcium cow comes out of her barn, yay! You know, raise the roof. Okay, so calcium cow comes out of the barn, and that moves troponin and tropomyosin out of the way. And then immediately, what's going to happen? They hook up. Okay, they hook up. So myosin and actin hook up. And what happens is that when they hook up, the myosin heads, as they grab onto the binding sites, will slide the filament to the center of the sarcomere. Okay? And then, okay, so that's what happens. So what's happening is that the filaments are moving to the inside or moving to the center of the sarcomere. They're like grabbing on and sliding to the center. Okay? All right, but here's the problem. Myosin is a little too attached, okay, and won't let go. Like literally won't let it go. Okay? So, if calcium cow is out of the barn, this moves this out of the way. These guys grab on, and then they won't let go. Okay? Except for one little thing. Okay? He's not supposed to be in here. Okay. There's another sorry. And it's ATP frog. Okay? Now, ATP frog, myosin can't help itself, okay? Because ATP frog is super magnetic. Can't help himself. All right, so as soon as ATP frog comes on the scene, myosin is going to let go, is going to hook up with ATP frog. Okay? But here's the deal. ATP frog gets used and gets played and gets tossed away, and then myosin goes back to actin and grabs on again. Okay? You probably know friends in which this has happened with, right? Okay? Use that analogy. That's exactly how
Awkward.
it works. Okay? So then it goes back, right? It grabs on. Okay. So then what happens is that the myosin head then slides the filament a little closer to the center of the sarcomere. So it slides even further. So what's happening is that the myosin heads are grabbing on, ATP frog hooks up, gets used up, lets go, and it goes back again, okay? And grabs on to the next binding site and slides and lets go, and then constantly it's like a little cycle, okay? It's like a little cycle. So this is all happening as long as calcium cow's out of the barn, okay? All right, so what do you think will happen if calcium goes back into the barn?
Troponin and tropomyosin come back.
Yeah, it's like, oh, she went away. And then it goes back down and covers it up. And as soon as it covers it up, this relationship is now over. Get it? Okay? All right, so it's the whole thing is all about really two important characters here. Calcium cow is the one that allows them to hook up, but that's, they're going to hook up, right? And then ATP frog is the one that gets in the way and gets played. Okay? And so it happens over and over and over. And this cycle continues to happen as long as calcium cow's out of the barn. Okay? So as long as calcium cow's out of the barn, this whole thing is running. As soon as calcium goes back into the barn, into the sarcoplasmic reticulum, the whole thing shuts off and it relaxes. Does that make sense? Okay? So, there's all these things that I described, there are like steps to it. Okay? So now you got to write down the specific steps. Okay? So